Okay, as we've discussed before, I want to start making these type of videos, and hopefully they prove to be helpful. The purpose of this would be that you would be able to watch these videos at any point in time. We will still do our regular class and do this work during class, but now if anything like unexpected happens during class, you now have the option to basically go back and look at the lesson from today in the form of this video and then be able to do your assignments. Alright, so just so that we know what we're doing here, we have a couple rules that we need to write down. So we have the product rule, which we did go over, and I do need you to know. So these ones we have gone over, and you need to make sure that you know what they are. So product of powers, quotient of powers, they are, this chart that I have here is slightly different from the one we've used, but nonetheless it still has all the same rules. Power of powers, so just the power rule, the zero exponent, and the negative exponent. So with this one, it just, the power of 1 is just very self-explanatory, so it actually wasn't even included on here, so I just put it here at the bottom. So make sure that you have those that I highlighted in green copied down. You can pause the video and copy them down, so I don't have to stay on this for a long time. So as long as you have them copied down, we're good. So now the extra two I will go over, but they are not part of what we've learned. They are also kind of like self-explanatory rules that hopefully make sense to you. Alright, so for this one, the product rule, we'll just review real quick. Make sure that you notice that we have A as my base, and notice that when we do our product rule, my base is still the same. So your base should never be changing. You should never be multiplying the bases. You should never be doing anything to the bases. They stay the same. The only thing that changes is our exponents. So right here, a to the x times a to the y is equal to a to the x plus y. Okay? So make sure we know that. The quotient rule, again, my base is a. My base does not change, because the only thing that changes is how many of this base I have. And the thing that tells me how many I have is the exponent, so that's the only thing we're changing. So I had x amount of a's, and then I divide y amount of a's. So a to the x divided by a to the y is equal to a to the x minus y. Okay, again, the only thing that is changing is how many a's I have in my equation now, not the number that I have, or not my base. Power rule, same thing. We have a base, and we keep that base. That does not change. Again, the only thing changing is how many we have, and what tells me how many we have is our exponents. So a to the x raised to the y power, the rule says you can just multiply the powers. Remember that anytime variables are right next to each other, it means multiply. The zero exponent, anything a to the 0 power is just equal to 1. Please make sure that you understand this rule fully. I've tried to explain it is that if we have 0 a's, I should not see a single a in your answer, at least for that part, because just keep in mind there could be a lot more things going on. But when you have anything to the 0 power, you are not going to rewrite the base at all. So make sure that you replace the entire thing with a 1. And I will be going over a couple more examples, hopefully, so that it's not too confusing. Alright, and then the negative exponent. So negative exponent, there's many ways to explain it, but just know that negative exponents are to show a very small number, not a negative number. These are representing small numbers, not negative. So we have a to the negative x power. So notice here, remember that we always have a 1 under anything that doesn't have a denominator, so this is not a fraction, so I put a 1 over it. My rule says that I flip it, or I do the reciprocal, and now I have 1 over a to the x, which means that my exponent now becomes positive. Okay, so this one's just going to be a little bit different. So with the 0 exponent and the negative exponent, things do just change slightly, so make sure that you know what we're doing. And as I stated before, basically the negative exponent just means if it was in the numerator, you flip it down to the denominator. If it's in the denominator, you flip it up to the numerator. And I'll try to explain that as best as possible in one of our examples. Alright, and then power of 1, anything to the first power is just itself. Think about it. If we say that I have 1a, that really just means you write down one little tiny a. So that one's pretty self-explanatory. Let's go ahead with more examples. So again, make sure that you have those rules written down. Alright, before we get started, please let's make sure that our base and our exponent are well explained. So remember that our base is what is being multiplied. So if you have not been doing your best taking notes, you can pause this video at any time and take these notes for yourself. And your exponent tells you how many times the base is multiplied. Okay, so in this case, what is being multiplied? It's 7. 7 is being multiplied a bunch of times, so my base would be 7. And my exponent would be how many times? So it was 1, 2, 3, 4, 5, 6 times. And so that was my exponent. Okay. So as long as we're clear with that, everything else hopefully will make more sense. Alright, so we have the product rule. We will be starting with. So I did this example in class, but if for whatever reason you missed it, I'm going to go ahead and do it now. So again, the rule says that if I have a to the x times a to the y, my base is the same and I just add the exponents. Remember that the only thing changing when we are doing these operations is how many of my base I have. My base does not change because I'm not doing anything to my base just yet. I'm raising it to an exponent, but that just means, you know, it's the base written a bunch of times. So let's go ahead. So my base here is 17. And then I have 17 to the third power raised to, 17 to the third power times 17 raised to the 10th power. So I'm just going to follow my rule, and I have a to the x plus y. So my x is my first exponent, my y is my second exponent. So it says keep my base, 17, and add my exponents, 3 plus 10. Keep my base, add my exponents. Okay, and if you do that, it should be pretty simple. So now we have (17 to the 13th power). But again, as I went over in class, all of this is pretty easy to explain, so I will. So this is saying that we have 17 to the third power. Remember that 17 to the third power means we're doing 17 multiplied 3 times, because my 17 is my what, and my exponent is how many times. And I'm taking those 3 17s and I'm then multiplying it by 10 17s. Okay, barely fit in there, but that is 10/17. So what you should notice here is that now I just have a bunch of 17s. So my base did not change. My base is still 17. What I'm multiplying is still 17. The only thing that changed is how many times I am multiplying 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So see, it does end up giving me my same answer that I got when I did my rule. So that'll be 17 to the 13th power just based on the expansion. So I can see that this is correct because this is correct. So my answer at the end would look like that. Remember, oops, sorry, forgot the one. Remember that when you type this, you do have to write 17, the little caret symbol, and then 13. Okay, moving on. I do have this example for you to try, so please go ahead and pause the video and try it out yourself. Okay, again, pause the video and try it yourself. Okay, if you didn't try it, shame on you, but please make sure that you are doing this. This is simply for you to learn. I'm going to tell you right now, your answer should have been 4 to the 11th power. If you do not understand how I did that, you will have to rewind the video and go back. Alright, quotient rules. So again, we have all of these rules telling me different things I can do with my exponents. So this one is my same base raised to the x and the y. When they're being divided, I subtract my bases. So that's what I'm going to do here. I have my same base, so I know I can use this rule. And I have exponent of 12, exponent of 3. Please keep in mind that it is always the top exponent minus the bottom exponent. So my base stays the same. And my exponent, top exponent minus bottom. Every single time, it doesn't matter if we have positive or negative exponents, it's your top minus your bottom. So my base and my exponents all check out, and that will equal 6 to the 9th power. Okay, and again, I can do the expansion to just show again that this does end up working out. Hopefully I counted correctly, and I believe that should be 12 sixes. Alright, so please remember that when we have factors at the top, remember factors are things that are being multiplied, and factors at the bottom, this only works when things are being multiplied. So because there are a bunch of factors, what I'm saying is that 6 to the 12th power comes from multiplying all of these 6's together. That's fine. And 6 to the 3rd power is multiplying 6 together. So if I'm multiplying by 6, that means I have a factor of 6. So top and bottom, I can divide by 6. When I divide by 6, let's say I divide by 6 here, that cancels out 1 6. Remember that the opposite of multiplying 6 is dividing 6. So if I'm multiplying a 6 and then I divide by 6, 6 divided by 6 is just 1, and that's all I'm left with. Same thing at the bottom, I get rid of that 6, I am left with 1 because 6 divided by 6 is 1. Get rid of another 1 because I have another 1 to use here. Remember that whatever you do to the bottom, you have to do to the top, which is why I can only cancel out 1 6 with 1 6. Okay, so you can think of it this way. The other way, in the virtual nerd video, they showed you that you could also just kind of like line these 6's up and make them their own equation. So like 6 divided by 6. Either way, you will see that you are left with 1. I mostly do this because remember that sometimes we have more at the bottom than we do at the top. So your answer would change slightly there. Alright, so I'm left with all of these. Remember that this is still multiplication. So we have 6 times 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 6. And then times 1 times 1 times 1, Multiplying by 1 doesn't change anything, so we're actually just going to rewrite it with just my 6's. So it is 6 to the 1, 2, 3, 4, 5, 6, 7, 8, 9 power. And then at the bottom we have 1 times 1 times 1 and no 6's left, so that's just 1. But remember that anything divided by 1 is just itself, so I don't actually need that denominator, and I'm just left with 6 to the 9th power. Again, these are exactly the same and makes sense with all my rules. Here's this one for you to try out. Again, pause the video and try it yourself. Pause the video. Pause it right now. Okay, and then if you paused it and tried it out, your answer should have been 8 to the 3rd power. Okay, so I'm going to show this part just one more time. Well, we'll just ignore that little part that I couldn't erase. But here we have our base being raised to 2 powers, so first to the x and then to the y. And then we're saying that that is going to equal to my base with the exponents multiplied. So here's my base, and here's my exponents. I go ahead and follow the rules, which tell me that this will be 75 to the 3 times 8, which is 75 to the 24th power. Okay, again, the exponent just tells me how many times, so that's what I'm going based off of. So here we have 75 first to the 3rd power. Remember that 75 to the 3rd power is just 75 times 75 times 75. So 75 3 times. But then they're saying that that amount of 75s we are raising to the 8th power. So if we're raising it to the 8th power, that means we are doing that 8 times. So we take our 75s and we multiply them 8 more times. So that's 2 times, 3 times, 4 times, 5. Okay, normally when I have time, I will go back and edit this just to like speed through for things like that. But in this case, I'm just gonna leave it like this. So sorry for the extra time. All right, so even though I couldn't write them right next to each other, all of these things are being multiplied. So we have 3 75s being multiplied 8 times. So remember that if I have groups of 3 and I have 8 groups of 3, that's the same as multiplying 3 times 8. If you don't believe me, you can go ahead and count and verify that this does in fact give me my exponent of 24. Again, notice that my base never changed. My base is the same. The only thing that changed is how many of them I have. So again, if I count them, that would be 24. And I have again proven that my rule does in fact work. Just so you know, in math, usually we use one example to prove that it works, but there is also many ways that they have proven that it works for every single number. And so you could do an example and try to disprove it all you want, but you will always end up seeing that it works. All right, here's your example. Go ahead and pause it and do the problem. And if you paused it and tried it out, hopefully you did, your answer should have been 16 to the 22nd power. Alright, 0 exponent. Again, there's many different ways that I can explain this. The first way that we explained it at first is that we always have an invisible 1. So if I have 1 times none of my base, so that means I am multiplying my base 0 times. That means it doesn't show up at all. Okay, so remember that the exponent is how many times, not the number itself. So if it tells me to write my base 0 times, then there's just a blank. There is no 0, it's just a blank because I'm doing that. It's not going to show up at all. So I am just left with 1. So anything to the 0 power turns to 1. Okay? Anything to 0 power, it just becomes 1. The exponent does not change, the base does not change, the entire thing changes to 1. So let me show you with using the quotient rule. So the quotient rule, remember, says that if I have the same base, which I do, I keep my base and I subtract my exponents, my top exponent minus my bottom exponent. And I end up with 87 to the 0 power, right? So at this very moment, you don't realize that it equals 1, but let's go back to the original one. It says we have 5/87, and also you can just look at it that we have the same thing divided by itself. So if we have the same thing divided by itself, I'm going to end up with 1. Remember that anything divided by itself is 1. So like 87 divided by 87, left with 1. 87 divided by 87, left with 1. 87 divided by 87, and again, and again. Okay, remember that this is just a bunch of 1s that were left from dividing out 87, so I'm left with 1 times 1 times 1 times 1. And at the bottom as well, so I'm left with 1 divided by 1, it equals 1. So even though I'm left with 0 87s, I basically just proved that it does make sense that it actually just equals 1. So anytime you're left with 0 of your base, you are left with 1. It does not disappear completely. There is a 1 left for it. Okay, and negative exponent. So negative exponent, remember you have a base to a negative exponent. We keep the base, but we do the reciprocal, which means we change it from numerator to denominator, and my exponent changes to 1. The best way that I can explain this would be that I have, let's say, 8 to the 3rd power divided by 8 to the 5th power. Right now, you should notice that we have more 8s at the bottom than we do at the top. So I'm just going to show you with the quotient rule. Normally, what I would do is keep my base, which you will be doing, take my top exponent and subtract my bottom exponent. Notice that I keep the same order no matter what. And then use a number line, use your rules, whatever you need to, but it's going to be 8 and then 3 minus 5. Remember that we are starting at positive 3 and we subtract 5. We keep the sign of the bigger number, and since they're opposite signs, we subtract and I get negative 2. If you use a number line, you can use a number line and just make sure that you subtract to the left. Okay, so we have 8 to the negative 2 power. But now I'm just going to go ahead and write this in the expanded form. So that means I have 8 times 8 times 8 divided by 8 times 8 times 8 times 8 times 8. So that's 5 8s. And I go ahead and do my canceling trick that I've been doing. So the reason why I'm able to use this is because I just showed you in the previous quotient example that this does work for all of them. So it can't be wrong to do it this way. So here's my 8s canceling out, 8s canceling out, 8s canceling out. Remember that we are left with just 1s when we do this. So at the bottom, I have a bunch of 1s times 8, which I know I didn't write it out the first time, but like here at the top, I'm left with 1 times 1 times 1. At the bottom, I'm left with 1 times 1 times 1, which is just 1, times 8 times 8. Remember that we are trying to leave things in exponent form. This is always that invisible 1, so remember that anything times 1 is itself, so I don't really need to write it that way. I'm just going to leave it as 1 over 8 squared. Now, the fact that it's in the denominator does matter. This 1 does matter. If it's in the numerator, it has to be there. The one that we don't need to write is when it's in the denominator. So we are now saying that 8 to the negative second power is equal to 1 over 8 to the positive 2 power. Remember that the exponent is telling us how many times it is there. So the fact that we have a negative exponent, it doesn't mean that we have a negative amount of 8s. It just means that it's actually a smaller number because now it's in the denominator instead of the numerator. Okay. So I could keep explaining it over and over and over again, but it does get a little bit more complicated, more than I would like it to, so I'm going to leave it at that. Just make sure that you know how to flip it. So with this one, I do feel like you need a couple examples. So like, let's do like 10 to the negative 5th power. Okay. Remember that we are going to flip it, make it a reciprocal. Anything that doesn't have a denominator has a denominator of 1. So we do 1 over 10 to the negative 5th power. Do the reciprocal. That's step 1. Step 2 is to change the exponent to positive. Okay? And then step 3 is simplify if you can. Okay? Simplify if you can. In this case, it becomes a little bit difficult to simplify, so we're just gonna just leave it like that. I could do 10 to the 5th power, but it's gonna be a pretty long number. Okay, and then so then here are the 2 examples. Sorry, I didn't give you an example for the 0 power and the negative exponent. So go ahead and pause the video and try these 2 out. Okay, and hopefully you tried them out. So again, if it's to the 0 power, that means I don't have any of that base at all written. It's just going to equal 1. And then for the negative power, remember it's right now it's in the numerator, which means it has an invisible denominator of 1. Okay. So you should know that there is now a 1 in the numerator. Remember, reciprocal means you flip it. And then we have 7 to the positive 2 power. Please make sure that anytime you flip it, the exponent becomes a positive.